Howdy folks! I've been unable to spend any time in the lab lately because of special circumstances, but I did go through some of my old footage and found something that might be of interest. At least if you have a big pot of coffee or a whole case of Mountain Dew to keep you awake. I could put you to sleep with old footage as easy as I can with new footage. So anyways, the chromium analysis, I had two tests, and it was for a specific mineral that really has no significance. So I'm cutting all that footage out, and I'm just going to save the footage on the chrome known and go over both of the test methods. And the first test method is actually mentioned in Orsino Smith as far as adding peroxide and looking for a blue color. But I'm actually following my reference Introduction to Semi-Micro Qualitative Analysis by C.H. Sorum. And that actually has a little bit more detail and also uses ether to isolate the peroxide. So that was that. And the second method is actually getting a green color with alcohol. And I got that from the Field Tests for the Common Mineral Elements by George H. Rosevar. So let's go ahead and take a look at that and learn a little bit about what I did with the chromium. I do want to go back and confirm the chrome, but I do want to do a confirmation test. And there is one that I dug up from a book. Basically, you oxidize it to from a +3 to a +6 to a chromate, and acidify it to get to a dichromate, and even take it a little further with peroxide to a chrome peroxide, which is a blue color. Unfortunately, it breaks down real fast in the presence of nitric acid, which will be in the solution. So what you do is you put a layer of ether, and the peroxide will be soluble in the ether and a little bit more stable in the ether layer. So you have the ether layer, so when it forms, it transfers over to the ether layer. The acid in the water stays in the water layer, and you should be able to detect the chrome peroxide and tell if there's chrome there. So let's give that a shot. I'm going to try it first with some potassium chromate that I have. This is some dialphyl ether I made about a year ago. It's getting kind of old. It is stored on potassium hydroxide to keep peroxides from forming that might be explosive. But it looks like the pellets have broken down, and it looks like the ether is cloudy. So what I'm going to do is wash it with water, take a little bit out and wash it with water to get rid of any potassium hydroxide. I assume that's going to transfer over to the water layer if there's any in there, and just clean it that way. So let's get started with that. Alright, I'm not going to need a lot of the ether. Let's see what this stuff looks like. Yeah, it's quite white. I assume that's just some potassium hydroxide suspended in there. I don't know if it's soluble in the ether or not, but I would think the water layer would extract that nicely. Let's throw in some water. Let's wash that up. But boy, look at that. I don't know if you can see the two layers, but they're both clear. So that really cleaned up the ether. I'm going to just keep that sealed, let the layer separate, and we'll use that further down the road here. Alright, here's a little potassium chromate. Just going to add a couple crystals here. This is a qualitative test, and it shouldn't take much material, that's for sure. Hexavalent form of chrome is carcinogenic, so you want to be careful and handle it with caution. And when you're done using it, you want to go ahead and reduce it back to a valence of +3. So that's the typical color of the solution of a chromate. In fact, I'm going to pour a little out. That looks a little strong. I'm going to dilute that down a hair. Alright. Now we're going to add some nitric acid and hopefully turn that to a dichromate. It should be orange in color. I'm just making this up as I go, so at least that's what I read. Well, it turned a deeper color. Alright, didn't exactly turn orange. Now we'll add our peroxide layer, or I'm sorry, our ether layer. Got plenty of ether there, more than I needed. So I was just careful just to take the top layer here. And now we'll add some peroxide and see if we get the blue chrome peroxide color. Sorry, but I forgot the camera. I did add the ether layer, and then I added the peroxide and it turned totally blue. So it made the ether layer look unnecessary. But it does store the peroxide above, and it is breaking down. I don't know if you can tell over time here, that's already lightened up dramatically. It was all even darker than the ether layer there. The peroxide isn't that stable, so. Well, the practice run worked with our potassium chromate. I don't know if you can still see the blue layer. That's starting to lighten in color. It's been a little while now. All right, this is chrome test number 2. I'm going to try it with some chromate, potassium chromate first. See what kind of results we get. We need to add some manganese dioxide to our dry sample. Now to a little bit of our sample and manganese dioxide, we're going to add a little bit of water. And some concentrated sulfuric acid, about an equal amount. And now we need to heat that to near boiling. Actually, not near boiling. We're supposed to heat that until it gives off some light fumes, I think. Boil strongly. Alright. Well, it feels like it's cooperating. It doesn't feel like it's going to explode out of the tube. Alright, I saw one white fume kind of head towards the top there. Either that or steam. So we'll give this a real good boil. Alright, that's definitely strongly boiled. So we're going to let that cool down, and then we need to centrifuge it. Alright, that didn't work because our solution stayed black. The manganese dioxide I got from a dry cell battery, and it's not very pure, so that might be the problem. So we're going to try it again, this time without the manganese dioxide, to see what happens. So there's a little bit of the chromate. You get the characteristic yellow color for the chromate, which we expect. I'm going to add just a little bit of acid. Alright, now that's forming the dichromate right there. That orange color. Not going to bother with the boiling. I am going to add a little more water. Okay, now supposedly adding alcohol and heating, this should turn a greenish color. We'll give that a try. Well, I'm going to add the alcohol before I light the stove for safety reasons. It doesn't specify what kind. This is a denatured alcohol that I think is about 50-50 methanol to ethanol. We'll give that a try. We're supposed to heat, and it's supposed to slowly turn green. Well, I'll be darned. I thought the orange color might be a little too strong, but I'm definitely seeing a little bit of a green. I don't know if you can pick that up on the camera. Let's see, let me grab a whitish background. It's not very strong, it's right at the top of the tube. I don't know if you can see that. The bottom of the tube is still orange, but we're getting a green color towards the top of the tube. Alright, it says we're supposed to boil. Alright, this is getting a little bit more violent as far as the boiling. But now that I got the temperature, and that's pretty much a boil, it definitely turned a greenish, almost bluish color now. Alright, so that looked okay for chrome. Well, that's it. I hope you stayed awake. The first method worked out pretty well with the peroxide. The second method with the alcohol probably needs a little work. I don't know if it's really right to eliminate the manganese dioxide in that. So that might need a little bit of fine-tuning. So anyways, thanks again for watching, and happy rockin' mineral analysis.